scientists and meteorologists to issue timely warnings and forecasts.
T-minus 30 seconds.
This will be NASA's Launch Services Program's 16th mission for NOAA.
Great partnership over the years we've had. Looking forward to this launch.
15 seconds.
And here we go. 10,
T-minus 10.
9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff of GOES-U, NOAA's newest weather satellite, to monitor the Earth and Sun in high definition.
Hear that all pressures, engines look nominal. Looks looking good as you see the Falcon Heavy soaring towards the heavens. All 27 engines powerfully lifting GOES-U on its trajectory and ascent into space.
A beautiful shot as we
Power
track
telemetry nominal.
the rocket from the ground here. The rocket is now powering down for max Q. Max Q is the moment of maximum dynamic pressure on the rocket. Max Q expected at 1 minute 7 seconds. The vehicle is now supersonic,
Falcon Heavy is supersonic.
traveling faster than the speed of sound.
Max Q.
There we heard the call for max Q, maximum dynamic pressure on the Falcon Heavy. Vehicle still performs very well. All data was nominal.
Great shot from on board the rocket, looking down on the Earth that it is leaving. And all 27 Merlin engines providing 5.1 million pounds of thrust. Coming up at T plus 2 minutes and 28 seconds, the side boosters are going to shut off while the center core will continue on. Wow, what a shot there of, again, all 27 Merlin engines firing off 5.1 million pounds of thrust.
The side booster cutoff will be referred to as BECO. We'll hear that call out. And then when the center core shuts off later in flight, we'll hear that called as main engine cutoff, or MECO. Side boosters are all boosters are performing nominally. Everything's looking good with the 27 Merlin engines.
Side booster separation confirmed.
There we see BECO and side boost.
MVAC chill.
Side booster separation. The MVAC is being chilled down, getting ready for ignition once the center core.
NY boost back startup.
And there we heard the call out for boost back startup.
A lot of things happening here. So again, we have the 2 boosters that are going to be returning to the Cape here, landing at landing zones 1 and 2. These 2 boosters have 3 burns, so we're seeing a boost back burn
All
now.
vehicles are following nominal trajectories.
Essentially, these boosters have flipped back and are returning on a path to the Cape here. There will be 2 more burns, a re-entry burn and then a landing burn. And these are going to provide quite a show for folks that are here on the Space Coast, because you're going to hear those sonic booms, Mick.
Yeah, absolutely. We are looking forward to those sonic booms as the side boosters land at landing zone 1 and 2. We're about 26 seconds away from main engine cutoff and the center core separating. Once the center core separates, we will then have MVAC, which is the Merlin vacuum engine for space, start up and get ready for what we call SES1, number 1. Today we have 3 burns for this mission to get GOES-U on its way, and this will be the first of those 3 burns.
TY boost back shutdown.
There we hear the 2 side boosters have boost back shutdown.
And now we're going to watch live footage there. There you go, of MECO. Again, the core
and ignition
booster separating from the second stage, and the MVAC engine on that second
fairing
stage
separation confirmed.
lighting up.
There we have confirmation the fairing has deployed. The fairings will are brand new fairings for the GOES-U mission, and they will fall back to Earth and be recovered by the recovery ship Doug. But SpaceX will look to reuse those fairings on a future flight, along with the side boosters. As we see there, they're coming back to Earth to land on landing zone 1 and 2. So things are progressing very well here. We are about 1 minute and 23 seconds from what we call the entry burn, where the plus Y and NY side boosters will fire up their engines to start slowing down the vehicle as it gets ready for landing.
Yeah, a lot to watch. Again, the left side of your screen, we are tracking the boosters that are coming back to the Cape here. On the right side of your screen, that is the MVAC engine on the second stage that continues to burn as it makes its way into the correct orbit to drop off GOES-U later today.
Stage 1 FTS is saved.
There we hear the autonomous flight termination system was saved as it returns back to Earth, making sure the vehicle is in a proper configuration for landing.
The second stage is currently taking GOES-U across the Atlantic towards southern Africa. And this is the first time, actually, a GOES satellite is launching on a Falcon Heavy. Only the second time NASA's Launch Services Program is using a Falcon Heavy.
Yeah, we launched our first Falcon Heavy with SpaceX back in October of 23 with the Psyche mission. And the side boosters actually that we used on the Psyche mission will be used for our future mission, Europa Clipper, this October. So brand new hardware today for GOES-U, and everything looks like it's performing very well. All the telemetry, everything looks nominal for the flight so far today.
Yeah, those who typically watch our launch broadcasts.
Entry burn startup.
There we heard the call out for entry burn startup. The vehicles are slowing. You can imagine this as a brake on your car where it starts slowing the boosters back down very quickly as they
entry burn shut down.
And there we hear the shutdown as the boosters have slowed down. Next thing we will see is the landing burn
NY FTS is saved.
at landing zone 1 and 2.
Beautiful imagery again.
Continue to follow nominal trajectories.
From the ground as we track those boosters make their way back to the Cape. We saw some birds fly into the camera's view as well.
Everybody wants to see the landing of the side boosters. As we said earlier, Megan, the landing will be exciting for a lot of people to see. Getting 2 side boosters coming back to landing zone 1 and 2, we will get those sonic booms. I know that you here in the MDC, we will get some
NY transonic.
We will
Stage 2 FTS is saved.
We will get some loud shaking right here in the Mission Director Center. I know a lot of people right here in Brevard will be excited when they hear the sonic booms.
NY landing burn.
Landing burns has started up.
Terminal guidance.
Wow, look at that. As it guides its way back down. So the 2 sonic booms here in the room. Our monitor's shaking as we watch these 2 boosters land.
2 side boosters choreographed their way down to landing zone 1 and 2.
NY landing confirmed.
We have successful landing of the 2 side boosters. Everybody looks great on the landing zone 1 and 2 as MVAC continues its mission with this first burn. And there we heard the call out for SECO, which is SECO 1, second stage engine cutoff for this first burn. And things look very good. The trajectory looks, we hear the call out there that nominal orbit insertion, everything looks great on the second stage performance for this first burn, Megan.
Yeah, and what you're looking at now, everyone on your screen, is the trajectory for the second stage of the Falcon Heavy with GOES-U. So again, it's making its way across the Atlantic towards southern Africa. This was the first of 3 burns for the second stage. The second stage will now coast for about 18 minutes before reigniting for its second burn. And if you look at the bottom of your screen there, we have a progress bar full of our milestones that we're covering during this live launch broadcast. And SES-2, that is that second burn we are talking about that will happen in, again, about 18 minutes from now. So Mick, as you said, so far so good. Really exciting launch.
Very exciting launch, and we got through that weather, and GOES-U's on its way.
Yeah, very dramatic and appropriate weather.
Absolutely.
As we and the launch team navigated that to see us lift off from the Space Coast at 5:26 p.m. Eastern Time. Again, we'll be with you for some of the milestones that you see on the bottom of your screen. But for now, let's turn it back to the host desk. Daryl and Alec, take it away.
All right, thank you very much. If you're just joining us, welcome live to the Kennedy Space Center in Florida, where we just saw GOES-U launch from right here at the Kennedy Space Center from Launch Complex 39A. I'm with Alec Krautman, who is from NOAA. I am with NASA, and this was a heck of a launch. We watched it out there together. It was interesting. I mean, that rumble and that roar. What do you think?
Oh, man, what a view. How did we get this weather window? It was outstanding. It was beautiful out there.
It was fascinating. You made the point to show me, like, look behind you. Here's these massive clouds that have accumulated behind us, far enough off to the west. But then as we look to the east, it was totally clear. Saw the thing go up the whole way.
Yeah, it's rocking and rolling New Orlando, but we were all good here.
I tell you, you got to love Florida. Appreciate them holding off those storms long enough to get this thing going. Well, now the satellite is surviving the rigors of riding a rocket into space now, but we've got a long way to go, Alec. There's a lot more to do. We've got another short burn and then a long coast phase before we have separation. And then a NOAA team will start commissioning the satellite. So as we jump ahead in the timeline, what else does that involve?
Yeah, so these satellites will be operated out of our NOAA Satellite Operations Facility in Suitland, Maryland. And over the next several months, they'll be, first of all, letting the satellite do outgassing for a period of time, and then calibration and validating and checking out the instruments. And then we'll see first light with the various instruments later this fall.
All right, looking forward to that. And we'll keep chugging along here on our broadcast. In 2021, people living in southeast Louisiana were hit with catastrophic damage from Hurricane Ida. But there was fair warning of what was coming, thanks in part to high advanced resolution imagery from GOES satellites. Here's a closer look.
Hurricane Ida will long be remembered for its destructive, deadly path that stretched from Louisiana to the northeast. For meteorologists at NOAA's National Hurricane Center in Miami, NOAA's GOES-16 satellite provided the advanced high-resolution imagery for closely tracking Ida and developing accurate forecasts from start to finish.
We did see in the GOES imagery the development of that low-level center that allowed us to go ahead and call that a tropical cyclone.
But for Hurricane Ida, it was a case of there being more than meets the eye, literally. Within the eye of Ida, GOES-16's advanced baseline imager saw 4 mesovortices. A mesovortex is a small-scale rotation in the eye wall of a tropical cyclone, and it can be a telltale sign that a storm is getting better organized and intensifying.
Yeah, when we started to notice the mesovortices in the eye, that was during a period of time when we were starting to see some pretty dramatic inner core structural changes.
And with those changes within Ida's eye, scientists saw its wind speeds go up and its central pressure drop. Both of those changes can make a hurricane's winds and storm surge more destructive and deadly. But Ida still had a surprise after it made landfall. The mesovortices in its eye continued to spin around the eye even while it was over southern Louisiana.
It's quite unusual for us to be able to see the mesovortices, say, hours after landfall. And the reason is because after a storm comes ashore, it typically loses its fuel source. It loses its the warm ocean water, and that causes the storm to weaken.
But Ida's mesovortices were still visible over land because of what scientists call the brown ocean effect. Researchers have found that some tropical cyclones can maintain their strength long after landfall, or even strengthen over land by tapping into the abundant soil moisture below it.
We think that the reason that the storm remained strong in this case was due to the presence of that marshy land. So it was almost like the hurricane didn't know it was over land. It thought it was still over the warm ocean water.
Hurricane Ida will definitely be a storm for the history books, and its full impacts are still being tallied today. For future hurricanes that threaten the U.S. and elsewhere, NOAA satellites will be our eyes in the sky to help forecasters stay on top of these monster storms.
T plus 14 minutes. Everything's good with the spacecraft and rockets so far. Let's check in now with NASA leadership. Philip Hargrove is with NASA's Sandra Connolly.
Yes, thank you, Daryl. I'm here with the Deputy Associate Administrator for NASA's Science Mission Directorate. Thank you so much for being here, Sandra.
Thank you so much for having me.
Yeah, I mean, what a day, what a moment. What was the launch experience like?
You know, absolutely fabulous. Beautiful launch. I could not be more thrilled. I have to say, I'm privileged to have seen several launches. Gorgeous day, and I actually got to see those boosters land. Fabulous.
What a show. So beyond the launch itself, what's exciting about the GOES-U mission for you?
So GOES-U is so important. As you know, it's the fourth in a series of geostationary satellites that actually support our weather, whole weather forecasting system. And so they stare over the U.S. or over the actual whole Western Hemisphere and provide us really critical data as storms are forming and evolving so that we can be prepared in advance of, during, and actually support after storms occur. So it really is an important satellite system for us.
Awesome. Can you talk a little bit about this connection between NASA and NOAA and how that has developed over the years?
Yes. So we have had a partnership for 50 years with NOAA. We have been building these kind of spacecraft. We develop them, we launch them, we commission them, and then NOAA operates them. And it's to support both terrestrial and space weather. Space weather is basically the sun's sending energetic particles towards, well, it's throughout the solar system, but it's when it comes towards the Earth that it can sometimes impact our power grids and cause problems for us here on Earth. So it's important to study space weather as much as it is terrestrial weather.
Awesome. And can you tell us about what's next in this NASA-NOAA collaboration?
Yes. So again, we've had a long-term partnership, so we continue to plan for the future. So there is a GeoXO series that is going to be the GOES-R series follow-on. So we're very excited to be partnering with NOAA on that. But also NASA has, on the space weather side, we have a mission called IMAP that's launching in the springtime. And we have a rideshare mission called Space Weather Follow-On, which is a NOAA mission. So we're going to be advancing our work in space weather as much as terrestrial weather.
Awesome. Very exciting stuff. Thank you so much for being here. Glad you got to witness that in person. And yeah, thank you again.
Thank you. It's fabulous.
All right. I'll send it back to you all.
Thank you. And we've been talking, of course, about GOES-U and the mission as we continue to track the rocket and spacecraft there, T plus 17 minutes, the second stage, and GOES-U making their way through space, getting ready for another burn. Alec, we want to talk a little bit about hurricanes. You were a forecaster, meteorologist in the Gulf, right? Louisiana, spent a lot of time there. Let's talk about the most deadliest and most destructive aspect of a hurricane, and that's storm surge. How can GOES-U help with storm surge? Is that possible?
Yeah, the deadliest aspect of a hurricane, definitely storm surge, the water in general, storm surge and inland flooding. And so from GOES satellites, we monitor the strength and intensity of the storm as it comes to shore. And after landfall, we have a flood mapping capability with our ABI. This is an image from our polar satellites and from the geosatellites with the ABI, and it shows the general extent of inundation after a storm. You can see this from the Louisiana coast after Hurricane Laura, and it gives emergency managers an idea of where flooding is on the ground. And using only our polar satellites, we can downscale this imagery to about 30-meter resolution. So this image that we're looking at now is from the polar satellites, and it gives you a better idea of where water is still residual in communities. And so this is residual water from storm surge and water from flooding from heavy rains.
So this is a valuable tool, as you mentioned, for emergency managers after a storm, because you got to know where your flooding is. You got to know where the people who are potentially stranded from that kind of water need help.
And to deploy resources and to coordinate response.
All right, very good. So continuing talking about hurricanes a little bit, earlier in the show we talked about NOAA's forecast for this year, and it's going to be a super active one. 4 to 7 major hurricanes with 110 plus mile per hour winds forecast for this hurricane season. Very important to the folks here in Florida and all the way up the eastern seaboard, as well as the Gulf. Why so many this year?
That's right. We're really seeing exceptionally warm sea surface temperatures across the Atlantic Basin, the Caribbean, and to the Gulf, and that's the main driver. We're also seeing weaker wind shear aloft. That would be a favorable environment for these storms to take off.
Right, and so when it comes to planning, it's really important that people have a plan. I think it's probably, every year we hear it, start a plan now. Most people, I think, or many people, I should say, probably say, I'll worry about that when I hear that's a storm coming. What are
I
your
think,
thoughts?
an active season forecast is a helpful reminder to revisit your plans every year, right? It really just takes one storm to impact your community, and so it could even be a light season, and if you get hit by a hurricane, then it's a big one for you, right? We had one of our Hurricane Hunter aircraft with us at Kennedy earlier today. So with our satellite imagery from GOES, the Hurricane Hunter aircraft, we're ready at NOAA for hurricane season. So we encourage everyone along the coast to do the same.
Alex been doing a great job answering my questions and showing off the instruments of GOES, but also throughout the show, we've been asking you to submit your questions on #AskNASA from the social media. So let's take a few more questions now, if you're good with that, Alec, and let's go ahead and start popping those up. We have Space Gamer on X asks, will there be any more launches for the GOES program after GOES-U, or is this the end of this part of the GOES program?
This is the end of the GOES-R series, and so next up will be GeoXO. So our future geostationary weather satellites will be this GeoXO series, with the first one scheduled to launch in 2032.
That's a ways from now, but the technology on GeoXO, how different is it going to be from GOES-U?
Even more high resolution for the current instruments. We'll have another imager. We'll have the lightning mapper. We're also adding new instruments, a hyperspectral sounder, an ocean color instrument, an atmospheric composition instrument, and that'll give us more information about our environment and our climate.
All right, another question. Let's go to Avincia. She asks, why are the satellites renamed? Why are the satellites renamed once they reach orbit?
That's right. So on the ground, we go by the letters. So this one was GOES-U. Once it reaches geostationary orbit, it'll be renamed GOES-19. It's indicative of the successful mission once it makes it. This is a risky process, and so it gets a new name once it achieves that milestone. And then we have the operational GOES-East and GOES-West positions.
All right, very good. Thank you, Alec. Let's send it back now to Philip Hargrove, who was on a packed balcony during launch with a member of NOAA's leadership. Philip.
Thanks, Daryl. Yes, I'm here joined by the director of NOAA's Office of Space Weather Observations, El-Sayed Talat. Thank you so much for being here.
I'm very pleased to be here. Very excited.
Awesome. Yeah. How was the launch? Tell me what your experience was like.
It was fantastic. It was picture perfect. It was beautiful. And the sound was just amazing.
Yeah, really, really was. So we've heard a bit about this compact coronagraph. Can you tell us a bit more about that instrument and why it's important that that's on GOES-U?
So the compact coronagraph, or CCOR-1, is the first operational coronagraph that we're ever going to fly in space. And it's an advanced solar telescope that blocks the disk of the sun so that we can measure the outer atmosphere of the sun, the solar corona. And it's very important to measure that because that's where space weather, extreme space weather events originate. These large explosions off the sun called coronal mass ejections that can send billions of tons of matter hurtling towards Earth at millions of miles per hour.
Right, so it kind of creates its own solar eclipse. I think that's what you told me earlier.
Yes,
right?
Basically this telescope will be able to take a solar eclipse and send it down to the forecasters every 30 minutes, within 30 minutes, so sooner than that. And it'll be the continuous operations of having a solar eclipse basically within 30 minutes continuously.
And can you tell me about how this instrument works with the other instruments on board?
So what this instrument does, it allows us our long-term forecasting in space weather. So 1 to 4 days after we see an explosion off the sun, we measure the characteristics of these explosions and put it into our models that propagate it towards Earth and see if it's going to come towards Earth, and then estimate how big the impact is going to be. And we really need to know that because that's important to protecting our technological infrastructures. These solar storms can affect the power grids, civil aviation, and other satellite operations, as well as communications and navigations. And this works in tandem with the other solar instruments on board that measure the solar and EUV, X-ray and EUV irradiance, and image the sun. And then the imagery of the sun gives us the context imagery of the sun that is basically like looking at the Atlantic basin for tropical cyclones as they develop, and then they might develop into hurricanes. We look at the sun with the solar ultraviolet imager to see if these regions of activity, which are centered around sunspots, if they're going to develop and produce flares and explosions, these coronal mass ejections. And we measure those effects with the irradiance measurements and the particle instruments that we have on the GOES satellites.
Very interesting. And then what's next for NOAA and with regards to space weather prediction?
So it's a very exciting time for space weather because we're developing, enhancing our capabilities. We are going to fly next year, in 2025, the Space Weather Follow-on L1 mission that is going to be an upstream buoy for measuring the solar wind and incoming solar effects, 1 million miles upstream of Earth towards the sun.
Very exciting stuff. Thank you so much for being here, and I'll toss it back to you, Megan.
Philip, Meg and I, again, are back here at the Mission Director Center at Hangar AE on Cape Canaveral Space Force Station, and we continue to monitor the teams as they continue the journey to deliver GOES-U to its correct orbit around the Earth.
Yeah, things are going very well. That first burn, all the telemetry looked very good. Nominal. The vehicle's in a coast phase right now. Our next step coming up will be SES-2, that second burn, which we should be hearing here in about 20-25 seconds. Things are progressing well, and GOES-U looks very good.
Mm-hmm. Again, the milestone bar at the bottom of your screen is where we are in the milestones to getting GOES-U into its correct orbit. SES-2 is that second burn that we're talking about, and we're tracking that for 26 minutes and 19 seconds. So 5 seconds from now. All right, and there we go. We see the MVAC engine on the Falcon Heavy second stage lighting up. This is the second of 3 burns for this engine. This burn is going to last about 1 minute and 27 seconds.
Things are going very well with the launch vehicle as they are on this trajectory that Mark Hammett's talked about, raising that orbit up to where we need to get going for that coast phase to head out to geotransfer. So things are looking very well, and all the telemetry on second stage is performing good, or the MVAC is performing very well, and telemetry looks like we are heading in the right direction, and the vehicle is performing phenomenal.
The image that you're seeing right there, an animation again of where we are, the trajectory that we have been keeping an eye on, and as you said, that we had an interview about earlier in the broadcast.
And there we see MVAC shutdown, and we are beginning this coast phase. Megan, things look good on the vehicle as we are watching the telemetry screens here from SpaceX. The vehicle performed very well during that burn. And there we heard the call out for a nominal transfer orbit, and we get ready for this long coast before our third burn. Absolutely, a long coast phase. We're looking at a coast phase of about 3 hours and 53 minutes. Again, this is a very well choreographed to the second trajectory that gets us to that geostationary transfer orbit that you're talking about. LSP's mission is to deliver GOES-U to that geostationary transfer orbit, and while it's there, they're going to do some checkouts of the satellite, and then once operational in geostationary orbit, that is where GOES-U becomes GOES East, and we'll keep a continuous watch over the Western Hemisphere. Yeah, as we get GOES-U on its way today, things progressing forward, as Alex said, very exciting to see the liftoff of the Falcon Heavy with GOES-U. Second stage is performing very well on that, and as we can see on the screen there, that stage 2 is coasting where it needs to get to, that normal geotransfer orbit insertion that we've heard about from Mark and Philip, and things are going to progress very well as the vehicle orients itself and gets GOES-U oriented on its way for that third burn, which will be a very important burn to finalize the mission to get ready for deployment. And part of that would be that the Falcon Heavy performed so well today that will that extra performance we had will give GOES-U a little bit of extra life on orbit because they don't have to use as much spacecraft fuel to get to geostationary. So vehicle performance looked very good today.
Yeah, GOES-U, the GOES satellites are designed to have 15 years of life, but because we are saving propellant on the spacecraft, because Falcon Heavy is delivering it farther towards its orbit, we are looking at a 20 plus
Almost
year
20
life.
years,
Yep. So again, just any other check of the spacecraft before we sign off for a little bit for this coast phase, Meg?
Nope, everything looks good on the spacecraft side. They are operating on batteries. As Mark said, they are on the right trajectory with the sun in the right position to get ready for deployment. And after deployment, they'll get some of their solar arrays out, partial solar array deployment, to be able to charge those batteries and get going, and then begin their work in the next few weeks to get to geostationary.
All right, so again, a coast phase of just under 4 hours. Mick and I are going to pop in at the top of every hour, so 7 and 8 o'clock p.m. Eastern time, to give you some quick updates about how everything's going. But for now, let's toss it back to Philip.
Thanks, Megan. Yes, I'm here with the NOAA administrator, Rick Spinrad. Thank you so much for being here with me.
I'm delighted to be here for this wonderful occasion.
Awesome. Yeah, tell me about the occasion. What was your experience like?
So this was obviously an awesome experience, seeing the launch. I've got to say that it's a seminal event. It happens over just a few minutes, but you realize there's years and years and thousands of hours of contributions from everybody, and see it come together so beautifully, so well done, so comprehensively is awesome in the literal sense of the word.
Absolutely. Thank you for that perspective. Can you tell me a bit about why this satellite is important to the nation?
So for us at NOAA, we feel that our main responsibility is providing environmental intelligence about the Earth so that people can make decisions about economics, about safety, about protection of property. This satellite is a critical component in our understanding what's happening in the Earth, the ability to watch it, see storms forming, see smoke moving, see all the changes in the patterns of the currents in the oceans, and use that then to provide decision support. All of this is contributing to what we hope will be a climate-ready nation. We can only be climate-ready and be prepared for the impacts of change and devastating weather and climate events if we've got the information upon which we can make decisions.
Right. And can you talk about how NOAA collaborates with NASA to get that information and achieve those goals?
We've been working with NASA for decades. It's a wonderful collaboration. In fact, if you look at the people at the launch here, many of them worked in both agencies for many years. And basically, to define the sort of swim lanes of responsibility, NASA is the acquisition agent. They have responsibility for making sure the satellite and the sensors are built according to the specifications. NASA also obviously provides the launch services that we saw here today. NOAA is the operator and manager, so when the system becomes operational, we also provide the funding for the acquisition. But by this spring, when GOES-U becomes GOES-19, it will be an operational satellite. That will be our responsibility to be monitoring the health and using the data 24/7, 365.
Awesome. And can you tell me about what you're looking forward to with this collaboration?
The continuation and continue to build the capabilities. NASA brings some incredible innovation to the table that we're going to build into the next generation of satellites. GeoXO is the continuation of the GOES-R series. We'll be launching GeoXO in about 2032, and between now and 2032, I expect nothing more than the continued great collaboration and innovation we've seen between NASA and NOAA over the last several decades.
Awesome. Thank you so much. That's some exciting stuff, so I appreciate you telling me all about it, and thank you for being here.
Thank you. My pleasure.
All right, back to you.
Thank you, Philip and Rick. And that was a nice burn that we just saw there. Still good things happening.
Nominal, on the way to orbit.
Yeah.
Sounds good to me.
Stoked about that. All right. So now GOES-U will coast for almost 4 hours before spacecraft separation. Alec and I are going to step aside during that time, but of course, we're going to be keeping track on what's happening. There'll be a live tracking animation of the journey the entire time. And of course, we'll have brief updates on GOES-U from Megan and Mick on the hour. But before we break, after the successful launch of a weather satellite, well, we want to celebrate a little bit by showing and sharing some of the best weather art submitted to us by kids from around the world. And the theme of this campaign, what was it, Alec?
Lightning.
We like lightning. And there it is. It's part of NASA's Space Place Art Challenge, where every month we invite kids to draw something space related or make some art out of it. You can see it's not all drawn. In honor of Go's U's launch today, we asked kids to draw what lightning looks like or make some lightning, and there were hundreds of submissions that you see there. If you want to see the rest of them, you can just scan the QR code at the lower right-hand part of your screen. You can see all 23 finalists. I even saw somebody made one with Legos.
Yeah, that was neat. And the Cascades, the Pacific Northwest made it in there. Lightning over Mount Hood. Wow.
Lightnings were striking Mount Hood. Yeah, that was cool. Good stuff. Thank you to all the kids who submitted that art. So now stay tuned for continued coverage of the GOES-U satellite during its coast phase. Alec and I will rejoin coverage at 9:30 p.m. Eastern Time to bring you the final third burn and live images of GOES-U separating from the rocket. Until then, have a good night.
Hey there, everyone. I'm Megan Cruz, and this is Mick Woltman, and welcome back to the live official launch broadcast of GOES-U. Now, GOES-U is NOAA's fourth and final satellite in its most advanced series of weather satellites, and it launched about an hour and 30 minutes ago from Kennedy Space Center here, Launch Complex 39A. Right now, we are joining you because we're going to walk you through some of what we expect to see in the next few hours, because right now we're in a coast phase, meaning the GOES-U satellite is coasting in space, waiting for its next burn. It's a third and final burn. But first, we want to take a closer look at GOES-U, right? Let's talk to you about what it looks like, what it does. GOES-U is about the size of a small school bus and weighs over 6,000 pounds. It has a 5-panel solar array that powers the satellite. Its instruments, computers, data processors, sensors, and also telecommunications equipment. GOES-U has 7 advanced instruments that can analyze weather hazards and environmental conditions, including hurricanes, lightning, space weather, the magnetosphere, and solar flares, and then relay that data back to us here on Earth. So really a great tool that we have here. And Mick, so far, how is the spacecraft looking as it continues to coast?
Yeah, during this long coast, almost 4-hour coast, we're an hour in. Things are looking great. Spacecraft is nestled on top of the Falcon Heavy second stage and continues to move along during this coast phase. But the team is very happy so far. They've done what we call a quick look data review of the ascent flight through that second burn, and so far everything looks absolutely nominal for the Falcon Heavy. That performance that Falcon Heavy gave us got us right where we need to be, getting ready for this third burn to get us for deployment into geotransfer orbit. So very happy with performance today and looking forward to getting to SES-3.
And these are live views from the spacecraft now and from the Falcon Heavy second stage that it's attached to. You're looking at GOES-U there wrapped up. And then that is the engine on that Falcon Heavy.
Engine on second stage.
Exactly.
Yep.
And you can see it's not burning. Again, it is not in a burn, and it is just coasting now and will continue to coast until about 10 p.m. Eastern time, Mick.
Yeah, it's everything's going great, and this coast phase is very important for us to get us where we need to go. Those live video feeds are amazing to see GOES-U in space, and MVAC looks very nice there. Things continue to go well. So looking forward to getting GOES-U where it needs to be and doing the science that it's made for.
All right, so again, a check of the clock. We are 1 hour, 36 minutes from launch. We will see GOES-U continue to coast until about 9:47 p.m. Eastern time. So hope you continue to follow along. Mick and I will be back at 8 p.m. to give you the latest updates as the team continues to monitor the second stage as well as the GOES-U spacecraft. Hey everyone, and welcome back to the live launch coverage of GOES-U, which launched 2 hours and 34 minutes ago atop a SpaceX Falcon Heavy rocket from Kennedy Space Center.
Yeah, everything's going well with the mission so far. On-time liftoff at 5:26 p.m. First stage performed very well. The data teams have looked at all the information on the rocket. Quick look for the first stage looks very good. Falcon Heavy performed very well. Second stage, those first 2 burns, right on target, getting us where we needed to go. Heading out to geotransfer orbit to get ready to deploy GOES-U. So far during this coast, everything has been really good. The spacecraft is healthy, and looking forward for SES-3, second stage engine start number 3, and deployment of GOES-U.
Yeah, and actually, let's take a look at the replay of the video now, because we can't not show people the replay of launch, right, Mick?
Absolutely, it was gorgeous.
10,
T-minus 10.
9, 8, 7, 6, 5, 4, 3, 2, 1.
GOES-U.
Liftoff of GOES-U, NOAA's newest
Vehicle
weather
is pitching
satellite,
downrange.
to monitor the Earth and Sun in high definition.
Gorgeous launch, Megan, right
Oh,
there.
yeah.
I loved watching that again. It was awesome to see it the first time, but amazing to rewatch that, as the team did a great job of getting Falcon Heavy off the pad today.
Yeah, and so GOES-U is the 4th and final satellite in NOAA's GOES-R satellite series, and these satellites provide continuous coverage over the Western Hemisphere, helping scientists and forecasters to put out timely forecasts as well as warnings. So, Mick, as you said, right now we have the second stage of the Falcon Heavy coasting. It's been coasting now with the GOES-U satellite for just over 2 hours, and we might have some live views that we can show people of this coast. This coast is very important, Mick.
Yeah, very important as it gets us out, heading out towards geotransfer orbit, which is where we want to drop off GOES-U. And then by doing that, they have saved some fuel, and they'll be able to use a little bit of fuel to get to geostationary and have a longer life on orbit. So awesome for GOES-U that Falcon Heavy performed so well today.
And as you said, we will coast until a third burn of that engine on the second stage. So we expect to coast for about another 2 hours until the engine reignites. We see that engine now on the screen. That shot that you're seeing, the left-hand side, that is GOES-U floating away from Earth.
Absolutely gorgeous to see Mother Earth there, and GOES-U traveling on its trajectory.
And then right there is the MVAC engine on the second stage, again, not lit up because we are currently coasting to a point when we will reignite that engine for a third and final burn. So our live coverage will continue until the launch team separates GOES-U from the second stage. That's going to happen just before 10 p.m. Eastern time. But before that, we want to check back in with you guys, let you know what's going on with the trajectory as well as the GOES-U spacecraft. So we'll be doing another check-in like this at 9 p.m. We hope you can join us.
Yeah, we're here all night.
We are here. Don't you worry. and welcome back to live coverage of GOES-U, the mission that launched about 3 hours and 34 minutes ago on a SpaceX Falcon Heavy rocket from Kennedy Space Center. GOES-U is the fourth and final satellite in NOAA's GOES-R satellite series. You see at the top there the Falcon Heavy rocket lifting off. Again, 3 hours and 34 minutes ago. GOES-U will help billions of people by monitoring weather and environmental conditions in near real time over the entire Western Hemisphere. So as you can see there in the video, the Heavy's 3 first stage boosters did their job. They got GOES-U out of the Earth's atmosphere. And then afterwards, the second stage continued on with GOES-U. You can hear the cheers from the crowd below in that video. So those 3 boosters did their job, got GOES-U into space. The top of the rocket, the second stage, with the GOES-U satellite, those continued on after this ascent. And now GOES-U has been coasting for just over 3 hours. And we've actually been able to show people live views of GOES-U coasting. Right here is one of those views we have now over the last 3 hours. Again, coasting now for just over 3 hours. That's a view there of GOES-U. And you see the Earth in the background, Mick.
Yeah, if you notice those views over the last several hours you've been watching, Earth has kind of come in and out of view. And there's a purpose that we have on the mission that's been going on. We refer to that as a barbecue roll. The vehicle, the second stage, and GOES are spinning at a slow rotation to help keep the second stage and GOES-U at the proper temperature. We want to make sure that the vehicle and the spacecraft don't get too hot or don't get too cold during this 4-hour coast period. And what's really cool is in that slow rotation, you see Earth coming in and out of camera view from that. So that was by design for the mission to protect the satellite and the second stage during this long coast.
Right. I mean, we see it right now. I mean, that first view that we had of GOES-U, we did see the Earth and we didn't see the Earth, and we can kind of see shadows growing a little longer on the spacecraft as well. So again, we talked about the trajectory for this particular mission, very complicated and in all things that they do need to consider. But the trajectory and everything, all the analysis, it looks good. Right now, GOES-U is about 19,000 miles above Earth, right where the team wanted it to be, right, Mick?
That's correct. Throughout this long coast that we've been going, our altitude has continued to increase during the coast phase, which is exactly what we wanted as we got the push we got from the second stage, second burn. And once we get into where we want to be for that geotransfer orbit, we'll have that third burn, very short burn actually, about 30 seconds, and we will then deploy GOES-U on its way. Again, Falcon Heavy performed very well today. The team has done a lot of data review, looked at that, and everything has performed very nominal on the vehicle and has put GOES-U right where we want to be so far in this mission as we continue on. And that extra performance we had from Falcon Heavy will give GOES-U that extra life on orbit. And I know the NOAA team is very happy about that. I think we mentioned earlier that the spacecraft was designed for 15 to 17 years, and this will give it about 20 to 23 years of life on orbit, and that is huge for weather forecasting.
Right, because of this third burn that's getting the spacecraft farther along the trajectory.
Correct.
Instead of the spacecraft having to do it, Falcon Heavy's second stage did it.
Absolutely.
Right. And since we're speaking about GOES-U again, how's the satellite looking so far?
Satellite's looking good. Teams continue to monitor it. As you see there in the picture, sitting on top of the second stage in that slow rotation as you see the shadows move across the bottom of the SEP ring there. But the vehicle, second stage, and GOES-U both look really good. So looking forward to continuing this mission.
All right, so this was our last little status update before our entire broadcast team joins you back on air again at 9:40 p.m. Eastern. That's to track the final mission milestones. You were talking about those, Mick, already, that third and final burn for the second stage engine of the Falcon Heavy, as well as actually separating GOES-U from that second stage. You see on our progress bar on the bottom of your screen there, again, tracking that third burn and deployment. So we hope you join us back here at 9:40 again with the whole team. We'll carry you through the rest of our live launch coverage of GOES-U. We'll see you then.
Good evening and welcome back to NASA's Kennedy Space Center in Florida. I'm Daryl Nail, and this...
I'm Alec Gravin.
He's from NOAA, the National Oceanic and Atmospheric Administration. Good to see you again. We had a very long coast phase, but now we're back for some exciting stuff.
Oh, it's been an exciting day. I can't wait to see that spacecraft out there on its own.
We're about to see that moment where it floats off into space, coming up in just a little bit. NASA's coverage of the GOES-U mission, which launched about 3.5 hours ago aboard a SpaceX Falcon Heavy rocket from the Kennedy Space Center, was started at 5:26 p.m. with a launch. If you missed it, here's a quick replay. And there you hear the rumble and roar at 5:26 p.m. Eastern Time. SpaceX lifted off their Falcon Heavy with a GOES-U satellite aboard, and it was a beauty. Facing east, it was clear skies as the rocket sailed up into space. Behind it, though, there were storms that stayed at bay off in the inland part of Florida. And looking down from the rocket, it was just a beautiful sight to see that rocket get off the ground and into space. People were excited and thrilled as the rocket roared, and we watched it go up, and that was the beginning of what would become a 3.5-hour journey that has led us now to T+ over 4 hours. And so here we are back waiting for this big moment. And you know, this satellite, once it is deployed, has a lot of features that's going to help a lot of people. And I want to ask you, first of all, after launch, we followed the mission, like we said, for 2 burns, and then we entered that coast phase. We're still in the coast phase now, but we're going to follow that 3rd burn and then spacecraft separation. Let's take another look now at this satellite, and then let's talk a little bit about some of the features and some of the things it can do. It's the 4th and the last of the GOES-R series of satellites operated by NOAA. GOES-U is about the size of a small school bus, and it weighs over 6,000 pounds. It has a 5-panel solar array that powers the satellite, its instruments, computers, data processors, sensors, and telecommunications equipment. GOES-U has 7 advanced instruments that can analyze weather hazards and environmental conditions, including hurricanes, lightning, space weather, the magnetosphere, and solar flares, and then it can relay that data back to Earth. Alec, NASA, and NOAA, of course, we've been launching satellites now, weather satellites, for nearly 50 years as a partnership. How does this particular satellite benefit the public?
Yeah, it's really the real-time 24/7 monitoring. We need the observations from the satellite to issue life-saving warnings for the protection of life and property, to track severe storms, track hurricanes, detect wildfires.
And new for this satellite, it's got a coronagraph on it, and now you're also going to be helping with solar weather.
Yeah, and this will be the first ever operational coronagraph, again, to get those warnings for space weather to industry users and to the public.
Where is the coronagraph? Because we got a model right here.
Yep, it is it's pointed on the solar platform, and so it is coming off.
Oh, right here.
Yep.
There it is. See? So how does that work? Like, you know, because the solar array needs to be pointed at the sun, the coronagraph also needs to always be pointed at the sun.
That's right. And so it actually sees with white light. And so the coronagraph, we also think it might be good, for example, at identifying comets as they pass close to the sun.
Now, there are 2 GOES satellites up there right now. Describe what they do, and then GOES-U, its role in displacing one of them.
Yeah, we have 2 operational positions. Goes east, it's over the equator, over the Atlantic Ocean, covers most of the eastern U.S., and goes west is over the equator, over the Pacific Ocean, covering most of the western U.S. And together they cover the entire Western Hemisphere from the west coast of Africa all the way down to New Zealand, the North Pole to the South Pole.
And we really need to have all the way to the coast of Africa, because one of the key things that this is a sentinel for is essentially, you know, hurricanes. I mean, these things that come off the coast of Africa and impact us severely need to be tracked as early as you can possibly do it.
And that's really the legacy of the GOES series. We had an awesome science session with the GOES team on Sunday, and there's a great quote from one of the former directors of the National Hurricane Center calling GOES satellite imagery the single greatest advancement for hurricane forecasting.
How about that? And you are advancing GOES into the next generation of weather satellites. As you mentioned, this is the last in a series. Tell me a little bit about what we can expect from GeoXO, which is going to be the one that succeeds this.
Oh, that's right. So our next generation, it's the first one will launch in 2032, and so that'll take us the 2030s all the way to 2050. It's incredible that they're already planning for this today. It'll have similar instruments, lightning mapper, imager, and there'll be some new instruments like an ocean color instrument to better understand the health of our ocean, and an atmospheric sounder, and so that will help us improve nowcasting of severe storms and to get profiles inside the storms as they form. And we will also have an atmospheric composition instrument, and that will help us understand air quality and the climate impacts associated with climate change.
And so your thoughts now, before we toss it to our commentators, about getting ready to watch this satellite come off the rocket.
Oh, to see it on its own in space, I can't wait. We got to visit GOES-U in the clean room at Lockheed Martin in Colorado a couple years ago, and knowing it was there and then on the rocket and now ready to go off on its own in orbit, I can't believe it.
All right, well, we've got a third burn to start us off first, and then we'll get to that separation. So this is the moment we've all been waiting for. Let's bring in NASA commentators Megan Cruz and Mick Woltman to walk us through the mission's last burn and spacecraft separation.
Hey guys, we're back again here from the Mission Director Center at Hangar AE at Cape Canaveral Space Force Station, and we want to direct you guys' attention to the bottom three milestones left in the progress bar on the bottom of your screen there. We see SES-3, SECO-3, and GOES-U deploy. Those first two are referring to the last and final burn of the MVAC engine on the second stage of the Heavy.
Yeah, it's coming up very shortly here. It'll be a very short burn, about 30 seconds. This will be the final burn to get GOES-U into the proper orbit and getting ready for deployment as we get ready for stage ignition. There we see the MVAC engine starting up for this burn. It's like I said, it's going to be about a 30-second burn, just maneuvering the second stage and GOES-U into position to get ready for GOES-U's deployment. And so far this mission, everything has looked great today. Megan.
Yeah, it's great to see the engine reignited again for this final burn. We've been watching this engine with the GOES-U satellite now coasting for about 4 hours, so it's nice to see it again lit up and reigniting for this final 30-something or so burn.
And there we see shutdown of the MVAC engine, getting ready for payload deployment, and we heard the call out for nominal insertion of orbit, getting ready for the GOES-U satellite to be deployed in about 8 minutes from now for the team to do that. So I can tell you that the spacecraft is working their procedures. They have powered up their inertial systems and getting things aligned and ready to go to get ready to separate from the second stage and deploy in orbit and start their work, as we see a picture there of GOES-U on the front of stage 2.
Yeah, and the GOES-U spacecraft now about 20,000 miles above the Earth, exactly where the team wanted it to be.
Yeah, exactly. Good trajectory today. As I said earlier, the data from the team, everything's looking good. Falcon Heavy performed very well. Second stage through this third burn has performed nominally, and everything looks good. Good insertion orbit, and we are just sitting waiting to see GOES-U start its science missions.
So again, the final dot that's left on our progress bar on the bottom of the screen is GOES-U deploying, GOES-U being separated from the Falcon Heavy's second stage, and we're expecting that in about 7 minutes now, so T plus 4 hours, 30 minutes, and 2 seconds. So again, watching the clock there on the top corner of your screen, waiting for this final milestone that we're covering on this live broadcast today. And one really cool thing, Mick, is we're going to continue to get these amazing live views from the spacecraft and capturing live views specifically of separation. This is going to be a first for the GOES mission.
Yeah, these views we've had through this whole coast period have just been incredible. To see second stage and GOES-U out in space, as you said, about 20,000 miles out. It's just been awesome sitting here watching these and being a part of this mission and enjoying it. As Alex said, this is the moment that we've been waiting for, and it's going to be very exciting to see it happen in real time on the video. That is going to be a first for GOES-U, and I know several members of this team.
Yeah. And GOES-U, will continue nearly 50 years of NOAA and NASA partnering together to keep a watchful eye on the Earth. And now with this new compact coronagraph, this new instrument specifically on GOES-U, different from the previous GOES-R satellites in this series, that's a really exciting ability to be able to add to this fleet of satellites.
Yeah, as Alec and Daryl talked earlier at lunchtime, this C-Core instrument is going to provide us a lot of great data looking at the solar flares and solar work that's going on that will help predict some things and help work out what disasters may happen because of those. And I think this is great. And as we said, GOES-U will be taking over for GOES-R once it gets on orbit. Today we're going to drop this off here and what we call a geotransfer, that giving a pinpoint area and giving more life to GOES-U. So things look very good so far as we continue to move forward, waiting for
GOES-U payload separation confirmed.
There it goes. We're getting a round of applause here from the spacecraft team behind us as we watch GOES-U float into space.
That is an incredible view, seeing
wow,
GOES-U with Earth there in the background. As you said, this is a first for GOES-U, seeing real-time deployment. I'm in awe. This is very neat photo to see there.
Yeah, beautiful imagery, an opportunity for the team to really see their work come to fruition, right? Teams have been working on the GOES-U satellite with SpaceX to get us to this moment right now that we are watching live on NASA TV. It's just wonderful to see their work at the beginning of its mission, really. I mean, this is the last mission milestone that we're covering on this launch broadcast, but this is just the beginning for GOES-U.
Oh yeah, there's a lot of work still to do. The team will partially deploy solar arrays to start getting the batteries on board power positive and charged, and they've got some other things they need to check out, as we heard from Alec earlier, getting ready GOES-U to move into geostationary orbit, and things are looking really well. That's just amazing, the live video from there. I've been doing this for almost 30 years, and I'm going to tell you, I enjoy watching the rocket launches. Every one is great, but this is really, really cool to see live spacecraft separation for this long of this important satellite.
Yeah, and to think about it again, wrap your heads around the fact that we are watching a live video from 20,000 miles above the Earth of this incredible tool being deployed into space. As you were saying, Mick, the first steps after this separation, there's a couple of things the team will continue to monitor, and that is in about 15 minutes, the GOES-U spacecraft will deploy some of its solar arrays, and then hopefully 30 minutes from now, the spacecraft team here can confirm what we call an acquisition of signal.
Yes, I know the NOAA team is very happy. They're working very diligently right now as they are getting things powered up and working the spacecraft and getting some low-level data on the health of the spacecraft, and things continue to move forward for this. So very happy to see deployment and them working on their process and procedures to get things moving. Very happy for GOES-U deployment.
Smile then.
I'm actually in awe. I'll be honest with you. Just watching the video that is just incredible.
Yeah, that was really cool.
Yeah, it's takes my breath away. It's like I said, I love this job. I love launching rocket stuff, but that's what it's all about right there is watching our spacecraft get on their mission and do the things they do. So, so I know Alex probably sitting at the host desk. He's very happy right now, and along with several of the spacecraft team behind us here in the Mission Director Center. So, congratulations to the NOAA team. That's incredible.
Yeah, just teasing you, but well said. As you said, it's a very cool opportunity to see the views that we got, and we actually, sorry, that was our bad. We kept talking over the QR code that our team pulled up on the screen. Guys, if you want to pull that QR code back up, that will take you to blogs.nasa.gov/goes. Again, blogs.nasa.gov/goes. Just scan that QR code there. That's where you can continue to follow along with this mission. So we'll be confirming the the solar arrays being deployed again in about 15 minutes, and then we will also be looking to confirm acquisition of signal in about 30 minutes. So all those milestones and well beyond will be following this whole mission on that blog that you see there. So congrats to NASA, NOAA, SpaceX, the U.S. Space Force, who got us through that tough weather to launch today.
Brian really, the LWOs today really earned their keep, and they did a lot of great. They found us that hole.
Yep.
And we were able to lift off Falcon Heavy. So another great mission, and I'm just excited for the whole team. It's again, I said it earlier today to somebody that launching rockets is a team sport, and it takes a lot of people to do this, and just very happy to be part of this team and working beside you and everybody else that got this mission successful today. So
yeah, definitely happy to have you here, Mick. Thank you so much. You added so much expertise and insight to the commentary today. So thank you so much. I hope to have you back here in the booth soon for another exciting launch, I'm sure. But for now, we'll send it back to Daryl and Alec.
All right, thank you, Megan, and thank you, Misty Mick. I think I saw a tear. He was getting a little emotional there, but no, in all seriousness, that was an incredible shot from the second stage of the SpaceX Falcon Heavy rocket, seeing that satellite, which was sort of blocking Earth, and then do a reveal as it goes off into space. Yeah. Unbelievable. Well, today's mission was managed by NASA's Launch Services Program, and the team considers spacecraft separation mission success. We have now with us Tim Dunn, NASA Launch Director for the day, and great day for LSP, wasn't it, Tim?
Terrific day, Daryl. I love being here with you. Alec, it's good to meet you. Good to be here.
Thanks.
But I do wish I was with the team right now, because as you experience the excitement of what we just saw with spacecraft SEP, to be with the team, either over at Hangar AE or at the SpaceX facility, there's just something incredible with the energy in the room of that final mission success that we put GOES-U exactly where it needs to be.
And you've had that experience many, many times over your years with LSP at the end of a mission, so it must be certainly special. Talk me a little bit through the early part of it, because this was a little exciting at the beginning, right? Because we had the weather in the area. We had a T0 of 5:16 p.m. Eastern time, and then we slipped 10 minutes. Tell me what happened.
So let me back up just a second and give credit where credit's due. So today's mission, the primary NASA launch director was Denton Gibson, and this was his very first as launch director for mission.
Dr. Gibson.
Dr. Denton Gibson, and I had the honor of backing him up on the mission, so he did a fantastic job of managing the team. And but as you indicated, today's launch felt a lot like one of those very active mission dress rehearsals that we have, where the rehearsal team is just throwing anomaly and green card after anomaly at us. We were dealing with some ground issues out at the pad. We had to get a red team back out to the pad after we had cleared the pad to fix one of the ground support equipment issues. We were dealing with weather, early weather, phase 1 lightning advisory very early in the count. That cleared. Anvil clouds started rolling in. The first one cleared. And we had a little bit of a launch vehicle discussion that we resolved quickly. But what really got us was what you indicated was that why did we move the initial T0 about 10 minutes to the right? Well, there was more bad weather moving in. We had the East Coast sea breeze clashing with the West Coast sea breeze over the peninsula of Florida, right about the Orange County, Brevard County line, roughly 30 miles to our west. and that was stirring up some really intense weather over there that we were then getting the residual anvil clouds that detach and drift over the pad. And those can have the ability to trigger lightning if we were to launch into them.
It's a constraint to launch, yeah.
Absolutely constraint. So we had a nice discussion with the launch weather officer. Huge props to Brian Sizik, incredible LWO, really guided us through the hole that we were looking for to launch through successfully. So what we saw was that we could have launched, had we committed to a prop load about an hour prior to launch, we could have been in a situation where at the initial T0 we would have been red, and that would not have been a good day for us. So we delayed. Brian recommended if we delayed about 10 minutes, we could avoid one of those red situations, and he was spot on accurate. We delayed the prop load, targeted 26 minutes after the hour there here on the East Coast at 5 p.m. And just a flawless final countdown. Very quiet, as active as the nets had been for the prior 2 hours. Very calm and quiet last 25 minutes. That was really nice.
That's the way you want it. And it was quite the sight. Alec and I were watching from right here at the press site. And, you know, in the direction of the rocket, it was clear skies. We looked behind us, and there's darkness over Orlando and Central Florida, but it just kind of held there.
Yes.
It just stayed there.
Yes.
So that really worked out for you weather-wise. And as you mentioned, great work by the LWO to make sure that you guys were in a good position to launch, because once you start tanking, you have to commit to that T0,
That's right.
So,
yeah.
Well, great. So we've got this launch, we've got the spacecraft separated. Talk a little bit about what's up for LSP. I hear we might be seeing these boosters again, right? That that launched?
Well, the boosters that were used today on GOES-U, those side cores successfully returned here to the Cape. They will be used again. SpaceX has not assigned these two boosters yet.
Okay.
But we will see some prior flown boosters on our Psyche flight from last fall. We'll see those again on our Europa Clipper mission coming up in October this year. But let me back you up for just a second. I want to throw a couple of more words of huge praise to two teams out there. The Space Launch Delta 45 range team, led by Colonel Meredith Begg. She and her team did a fabulous job of clearing downrange for us, and all of the instrumentation that we needed here at the Cape performed flawlessly. It was a daytime launch here in the summer of Florida. There were a lot of boats offshore that we needed to ensure that all the areas were clear. So that surveillance control function that the range provides us performed magnificently today. So Colonel Begg, thank you for that. And then also, we don't go anywhere unless our launch provider takes us there. And SpaceX did an incredible job. So thank you to the wonderful work of SpaceX, both the Hawthorne team and especially the team here at the Cape. Just worked great to get us right to T0 and get us on our way to space. So let's talk about what lies ahead for LSP next.
Okay.
Yeah. So this fall, we are going to launch another Falcon Heavy. We're on our way to the moon Europa, one of Jupiter's moons. Very exciting, thrilling science mission. Europa Clipper is the name of the mission. We'll fly on a Falcon Heavy October 10th of this year. We're going to refly those side cores that we flew so successfully on Psyche last October. And then we got a couple of missions coming up in 2025. We've got a mission called SphereX from Vandenberg. We've got another one called IMAP from here at the Cape again. So those are the big primary missions for LSP that are coming up. And then we're going to be having some fun with our Vader contract, where we're able to take a little more risk with some exciting spacecraft. We're going to send some spacecraft to Mars later this year on the first flight of the New Glenn rocket from Blue Origin.
Right,
So
and a lot of people looking forward to
that mission's
that
called Escapade. So
Yeah.
very exciting mission there. And then we've got a couple of missions. One's called Thesis 2 and one's called Tracers, and we'll get those off in 2025. Also Vader missions.
That Blue Origin rocket, I mean, it's built right down the road, and I think that'd probably be the first time, right, that we have that kind of setup where they roll the rocket from where it was built right out and launch one of these LSP missions.
Yeah, there may be some launch historians out there that can correct us, but in my understanding,
you've been there a long time.
the first time I can ever imagine hardware being built right here in Brevard County and launched here as well. So that's exciting for us.
And a lot of excitement about Europa Clipper. We're going to an icy moon. It's generating a lot of buzz.
Yes.
So we're looking forward to that. And you mentioned, I mean, the side cores that we launched today, you guys, I've been around LSP for a while now. You do like to come back to those boosters that you've run, through the ringer and understand, very closely.
Yes.
So you might be seeing them again.
We might see these. SpaceX hasn't made all of the future assignments with these, but we do have some other heavy missions coming up beyond Europa Clipper, Roman Space Telescope in a couple of years, so that one will be exciting. So we could see these boosters again.
Yeah, you like to see those boosters come back. Well, appreciate it. Tim Dunn, Launch Services Program, thank you for coming and joining us. And really quick before we sign off, there's still a lot more to do. NOAA has to commission this satellite. It's off. It's separated from its spacecraft, but there's some things it's got to do, like it's got to get
just
solar
tonight.
arrays
Solar array deploy, power positive. We should hear about that really in the next 30 minutes. So.
Yes.
So if you want to make sure that you stay tuned to the blogs, we'll have all the updates about how the GOES-U spacecraft is doing as it moves towards getting commissioned and then becoming that GOES East satellite. So that'll do it for us here at the Kennedy Space Center for this live coverage of NOAA's GOES-U. Big thank you to everyone who participated, and partner, I really appreciate you being here.
What a day.
Yeah,
Thank you, man.
Well done, and congratulations to you and the NOAA team. You can continue to follow this mission by scanning the QR code that'll pop up right now on the lower right of your screen. That will take you to a website, noaa.gov/GOES-U, and you can follow all the latest updates there. We leave you now with another look at that spectacular GOES-U spacecraft deployment. Thanks everyone for watching, and have a great evening.